second part of section 11.5, we're still going to look at areas of circles and sectors, but also some applications and some piecing together of random shapes here, and kind of reviewing all the area formulas we've had for the chapter. So in these pictures, we're finding the shaded area. And one thing you might notice is, like in this first example, it's definitely two sort of shapes put together. So I'm going to have to find the area of this, what would you call this? A semicircle, right? And then the area of this triangle, and add those together, right? They would just be the total area of those two things. So I'm going to write down area of semicircle. That looks bad. I'll do it this way, semicircle. Plus, I'm also going to need the area of my triangle. Alright, let's think about this for a second. What would the formula be for area of a semicircle? This is half of a circle. Now wait, I know the area of a circle would be pi r squared, right? And if it's a semicircle or half of it, I need 1/2 of pi r squared. Then I'm going to need the area of a triangle. What's the formula for area of a triangle? That is 1/2 base times height. Now let's plug in these values and I'll be able to figure this out. So 1/2 of pi times, okay, I need the radius of the circle, and then I need to square that 1/2 because it was 1/2 pi r squared. Well, it looks like 7 is the diameter of the circle. So the radius of the circle, half of 7, would be 3.5. And we're all set with the semicircle. So what about for the triangle? 1/2 base times height. What are the base and the height of this triangle? Well, you know what? It's a right triangle. So the base and the height can be considered the two legs because a height goes at a right angle to its base. So actually 7 and 7 are the base and the height. So let's see here. I'll do the first part. 1/2 times pi times that 3.5 squared. Now this first part of it is 19.24 plus, and then I have 1/2 of 7 times 7, half of 49, is 24.5. Let's combine those together. My total area then is 43.74. These measurements were in feet. Area is feet squared. So an example where I was just adding two areas together. In this next example, I want the shaded area. This is kind of like maybe a tube. If you were, on the lake tubing, or I guess on the snow, or maybe something like a donut or some sort of thing. But I want the shaded area here, and there's two circles. And you're thinking, well, how do I get just the shaded area here? Well, if I took the area of the big circle, and then I also had the area of the little circle, what would you do? I don't want the whole area of the big circle. I only want this portion. I actually don't want the little circle at all. What if I took the area of the big circle and then I subtracted out the area of the little circle, right? It's like I had all of this shaded area of the big one, and then I take this away. Then I would only have what's left, which would be the ring in between. So area of a circle is pi r squared, right? So pi r squared for the big circle minus pi r squared for the little circle. If we're taking that little circle away from the big circle, we'd have what's left. The radius of the big circle, that 7 does refer to the entire thing there. So that radius of the big circle is 7 minus pi times radius of the little guy is 4 squared. Instead of going to a decimal yet, I could do like 7 squared is 49, so that would be 49 pi. 4 squared is 16, so that would be 16 pi. And then 49 minus 16, I could give an exact answer here, that's 33 pi. That would be an exact answer, and this would be area of inches squared. But also, since I probably want a decimal, 33 times pi, I'm getting an area of 103.67, it looks like. And again, inches squared, because we're talking about area being squared. So this was an example where I had to find an area and subtract out some area that I don't want from it to leave what's left. And then another example here, and this one's really kind of cool. I want to find the shaded area again, which is everything in between these two circles taken away from a larger circle. So we have like this one really big circle, and I don't need the area of the whole thing, but I need the area that's left when I take away these two circles, right? These don't count. So I guess like I need the area of a big circle, this whole thing. And then I'm going to have to take away, subtract, the area of two smaller circles. Right? Something like that. The area of the big circle, take away the area of two smaller circles. Well, the area of a circle formula is pi r squared, I know that, minus the area of two small circles. Well, the area of each of the little circles, again, is pi r squared, but I'm going to have 2 pi r squared, right? 2 of these circles, okay? Question is, what's the radius of the big circle? Well, the radius of the big circle would go from here out, and I'm going to use this smaller circle because that'll kind of help. Notice the radius of the small circle is 3. So if I looked at the radius 3 going here, another radius 3 going here, the diameter of the little circle is 6, which means that's actually the radius then of the big circle, right? Diameter of this was 6, the little guy, but that's the radius of the big circle because it goes from here to the outside. So pi times 6 squared minus the 2 little circles. Each of those little circles has a radius of 3. So 2 pi times 3 squared. Again, let's simplify before we go to the calculator. 6 squared is 36 pi would be the area of the big circle. Minus 2 little circles. So 2 times, oh wait, I'm going to get rid of that 2. Because 3 squared is 9. 9 times 2 is 18. So that would be 18 pi. Hey, look at that. 36 pi minus 18 pi is actually 18 pi. It looks like the area of the 2 circles, 18 pi, is the same as the area of the shaded sections, 18 pi. That's kind of cool. And that'll always be the case if you have this exact shape. You have a large circle, 2 smaller circles, creating or going all the way across. You'll always have the same shaded area as the area of those 2 circles coming out, which is kind of neat. As a decimal, this is 56 point, oops, 0.55. And we got feet for a label. This is area, so feet squared. So today, looking at combining all the area formulas we have, whether we're talking about circles or triangles or back to rectangles, etc. But looking at examples where, like this one, you're going to combine areas, add them together, or areas like the examples like the last two where you're going to be subtracting and like taking away areas from what you already have. Okay, so looking at combining everything we know today.